today I would like to talk about our use case that we had in our company to actually reduce our RPC calls to our provider. And the whole presentation is just an excuse to encourage you guys to explore or look into the transactions and how they work from like a deeper level. So just have fun with the transactions and explore blockchain. And before we start, I would like to also present our company, Oasis.app. So we provide like an interface to different protocols, DeFi protocols. We started as a maker interface, and right now we're also integrating the Aave. We provide different strategies over there and also automations. All right, so let's go back to the business and let's remind ourselves some basics. So we will be talking about the RPC nodes. So those are like gateways to blockchain, which we query to get data and also send transactions. The next thing that we will be looking into are the transactions itself. And what we are interested in are the data, so the data part of the transaction. And the next step, I will just show you how to decode, because at first it might look like a gibberish to you. And actually today we had pretty great presentation called What the Hex that showed how to decode those presentations. Here will be just like a reminder and a short example how it does. So you can see the first 4 bytes on the data presents what functions are we calling on the blockchain. So this one is like a 4 bytes of the hash of the function signature, and the rest are the arguments. So you can see the address, which had to be padded to fill the 32 bytes, and also this one single one, which represents the Boolean value. So I think we've got the basics covered. And let's go back to our case. So in Oasis, we provide user with a lot of data fetched from different smart contracts. So in order to get information about your position in Maker, we have to call multiple Maker contracts. And it takes like a lot of calls. And furthermore, we would like to keep the data up to date. So we have to pull the blockchain every few seconds to fetch the latest data. And that creates like thousands of calls for each user. And our node provider was like that, like, please no, don't do it. You have to find a better solution for that. And one of the solutions that we explored was to use a multicall. So what's a multicall? Multicall is basically a smart contract that we call and that allows us to aggregate all the calls, batch all the calls just in one RPC call. So instead, as we seen there, instead of making 100 calls, we can batch them together into one call. Thus, the Infura or Alchemy will count it as just one, not 100. And furthermore, what it creates, all the responses are coming from one block. So if it's important to you, the multicall also assures that all the data comes from within one block. Okay, and this is the whole code of the multicall. You can see it's pretty simple. It takes this small struct, the target addresses, so the addresses of the contracts that we want to call, and the call data. And we already seen how the call data works. So the call data that we will be sending will contain the first method signature and then encoded parameters. And you can see also there, it should return us a block number and all the return data from the smart contracts. So you can see we're calling our target smart contract with the call data, and it's assigned here to the return data. So you can see it's pretty simple, like really simple smart contract. And this one is actually deployed by the Maker team. You can search in their repository on the GitHub also. And right now, I would like to, it's really barely visible. I hope you can see it. I would like to show you some example how we can call this smart contract. This is the address of the multicall, this one. There's pointer. Whoa, it's amazing, right? All right, so we will create this make multicall function that will get the contracts that we would like to call, the function name, and the arguments that we would like to pass to this function. First, we just create the instance of the contract. And as we already seen, that the aggregate function requires this small struct, right? It wanted a target contract that we want to call with the call data. And this part is exactly what we are doing. So we are providing an address of the contract and also the data that we will be sending there. And the call data will be like an array of such a tuples. And this call data, we are just calling to aggregate, and then we get the data. But again, the data returned will be just some hex values that we need to somehow decode, right? And in order to make our life easier, we can use already passed contracts. So the contracts to decode the function results with the function name that we provided and the raw data, because you can see the raw data was returned from the decoded aggregate function. And after everything, we just return the result. And additionally, we can return the block number in which the call was executed. I can share you the presentation over there. There's a link to Code Sandbox with everything working. But basically, the usage of this function looks like that. You can just provide a VAT. VAT is like a core smart contract of the maker. Call two functions like ilgs, for example, and the dead with arguments. And over there, you will return everything that you needed. And that would be it. Thank you very much. And I hope it encourages you to explore blockchain and calling blockchain further. Any questions? Yeah.
I have one question. You said that all the calls are executed in the same block,
yes,
which is great, but can you actually specify the block that you want to use, or is just the latest block?
I mean, it would depend on your RPC node, because here you've got provider call with the call data, and I guess you could try. I just want to show you the example. Also, so this would became such a RPC call, right? To the multi-call with all the data, it will be encoded. And here, I guess if you would specify different block number, it should return you different data based on your block number. But it will also depend on your an RPC provider.
Okay,
I know that Infura in basic plan, or Alchemy supports it in the basic plan. I guess Infura does not.
Okay. I have a question.
Yes.
I'm curious, do you have numbers around, like, by using multi-call, how many, like, how were you able to reduce the amount of calls you were making to the node providers, or even how much money were you able to save by doing that?
Well, the whole case was that we are exceeding the limits that we are allowed to, so we had to reduce in order not to charge to be charged more in the future. It's still under development because there are few things that we didn't think of through, because for example, reading prices is not that simple. On the Maker protocol, you have to pretend that you are a different contract. So you have to pretend that you are spot, because so we are trying to do it like that. But yeah, it reduces the calls really greatly. Like you can see, in order to get some data, you need to do up to 100 calls, and then you just do it in one.
Thank you.
Hello, thank you so much for the talk. I really appreciate it.
Mm-hmm.
I will definitely use it because I actually have a use case in mind for that. But I was just wondering maybe if there is something on the client side, I mean the implementation side, whether there is maybe some JSON RPC improvement which you think might help with these kind of issues. But also, you are mentioning that the motivation was that you are over the limit in your provider. So why don't you run your own node, which is like pretty trivial, and you get archive node and.
We've got our private node, but I don't know why we didn't choose this approach. As I
it
said,
can
like
definitely handle that many calls if you have it on your own server. So like.
yeah, actually, there are multiple things that we are trying to do in order to solve this case. We also trying to cache some of the calls, because like imagine we've got like hundreds of users cache asking for the same data, so it doesn't make sense to do it. So we are like this is one of the approaches that we are considering.
And the first question was, sorry, I was just like, the first question was that whether there is something on the client side, on the implementation side to improve this, whether some like the JSON RPC performance, like for example in Aragon, it's pretty good, but.
So I don't know if it would answer your question, but you can create different providers. Like there's also this one provider that is called batch provider that will automatically batch your calls, but it's being sent as an array of the calls, like array of such calls. And Alchemy or Infura actually changed the pricing, and they are counting all the calls inside.
Yeah. I know there are like Go and allows it, for example, like to do it in one call. But I didn't know that they charge for each one.
They're charging
nice.
each call inside.
And another thing you could do, like there is Dshkl. It's like a balancer and also cacher for endpoints. So I have it pointed to my own node, but as a fallback also Infura, and you can balance between many endpoints, and it also has caching. So that can really help with like the providers.
Actually, this one is also a pretty good idea. Thank you.
Thank you.